Author and international speaker Jay Seegert holds degrees in both physics and engineering technology. As founder of the Starting Point Project, Jay passionately seeks to help people establish a biblical worldview based on the authority of Scripture. For the past 38 years, he has been graciously tackling tough questions regarding the Christian faith, especially in the often intimidating world of science, bringing it down to a level that everyone can understand. We trust you will enjoy this presentation as Jay delivers a fascinating talk entitled Creation in 6 Days, a Scientific Analysis, Part 1.
Well, welcome back to Creation in 6 Days. We are on part number 3, but it's the scientific analysis. It's our first session discussing the science behind all of this. So it's part 1 because we're going to spend 2 sessions. There's so much we could spend 4 or 6 or 10 sessions on the science, but you'll get the gist of it. And I'm going to go over a lot of examples. I'm going to basically be, at some points, introducing you to certain topics without going really, really deep, because we could just take one and go for hours on that one, and it wouldn't be that beneficial, and it gets a little too deep. So I'm going to throw a lot at you so you get a feel for how much evidence there really is from science behind the literal 6-day creation view. So that's what we're going to be taking a look at here. And follow the science. We've been hearing that, recently, especially with all the COVID things a number of years ago. And I say follow the science because, again, in most people's minds, they're tolerant of hearing what the Bible says, but they're like, okay, can we get to the real action, the science? Because science is really what's going to tell you how old the earth is. The Bible is just a religious thing, and it's vague and all that. Science is going to tell you. In reality, it's just the opposite. If the Bible is truly the inspired Word of God, everything it says is true. And we just spent a session going through what does the Bible say, and it's been pretty specific, not giving you an exact number. I don't care how old the earth is. Honestly, I do not care. Now, from my studying, I lean very heavily towards thousands of years and a literal 6-day creation, but the exact number isn't that important to me. I think the biblical narrative lays out about 6,000 years, but the exact number isn't important. That number isn't more spiritual than 13.8 billion years. It's not about an exact number. It's about a general time frame, and I think the Bible supports more like a 6,000-year time frame. And the Bible can tell us that because it's an eyewitness account from God, telling us things that are inspired, inerrant, cover to cover, whereas science, there's a lot of interpretation and assumptions that go on, and they're changing their mind all the time. So it's not as exact as you'd think, and that's what you're going to see from these 2 sessions here. Here's a very important point. It's the only time in my entire career and all the talks that I've given that I ever talk slow, and it's when I say this. There are no clocks in nature. None, nada, zip, zero, zilch. What am I trying to say? There aren't any clocks in nature. People are like, wait a minute, we got radiometric dating, you got this, carbon-14 and all these things. No, there are no clocks in nature. What we do have are processes. We have lots of those, lots of things that are happening. And by taking the processes and making assumptions about them, we can get a clock. You'll see that in a second. This is just a small sampling of processes, things that are going on. We have continents eroding, salt entering the oceans, population growth, and on and on. We're going to talk about a number of these actual processes that no one denies. They are processes. And by taking the processes and adding assumptions, then you can turn it into a clock. And the background screen here has various clocks, and they're kind of warped. That's subtle, and that's intentional. These clocks don't always match each other, and they're off a bit. That's kind of the point I'm making with the graphic there. So we're going to take a general intro to science, looking at the limitations and assumptions, and then we're going to look at an overview of radiometric dating, including carbon-14, and then we'll look at some evidence for recent creation in 2-part series here. First, starting out looking at limitations and assumptions. In many of these scientific processes that we look at, they're not giving you an exact date for the age of the earth. They're just giving you a limit. It's just saying, according to this process, the earth probably can't be any older than X amount of years. It doesn't tell you how old it is. It just kind of puts a limit. Okay, it probably isn't any older than that. Could be younger, easily could be younger, but it probably isn't any older. There are limits, and that's what we're going to see with these processes. And here's an analogy, because I want to keep this simple for everyone. Even though we're talking about science, I don't think any of it will be over your head. I'm going to keep it really simple, especially with analogies. So let's say there are two guys walking up to an old gold mine out west, and they get closer and they notice it's caved in. And they're trying to figure out how long ago did this gold mine cave in. One guy says, oh, I think it caved in maybe like 500 years ago. And the other guy says, well, how long have we had gold mines in the United States? We haven't had gold mines that long, maybe 220 years. They still don't know when it caved in, but there's a limit. Must have caved in less than 220 years ago, because if it was before that, we didn't have gold mines. That's not a possibility. So they don't know when it caved in, but there's a limit now, 220 years. They get closer, and they see a digital watch that was buried. Whenever it was caved in, it buried a digital watch. How long have we been making digital watches? 30, 40 years? They still don't know when it caved in, but there's a further limit. Had to be less than 40 years ago, because if it was before then, it couldn't have buried a digital watch. Then they look at the watch closer and they notice it's still ticking. Well, how long do batteries last? I don't know, maybe 3 years or so? They still don't know when it caved in, but there's an even further limit now. It had to be less than 3 years ago. If it was prior to that, the battery would be dead by now. So you can see how we're using processes and we're coming up with limits to get an estimate. Again, it could be younger, but probably not any older than that. So that's a little bit about limitations. Let's take a look at assumptions. This is huge. Even if we grant all the assumptions that they want to use behind these processes, and I'll explain those in a minute, even if we give them all those, which they're not good assumptions, but we say, fine, have your assumptions, 90% of all the methods that you could use, meaning all the processes that are out there, they yield ages that are far too young for the secular narrative of Big Bang and evolution and all that. 90%. But they ignore those because it doesn't work for them. They hold on to the small handful that gives them millions and billions of years. So we will talk about radiometric dating, which is very intimidating for a lot of people. They're like, that's why I don't get into the whole age of the Earth, because you got the scientists in the laboratory doing the radiometric stuff, and I don't know anything about that, and what am I supposed to say? I'm supposed to argue with them? So I get that. It's kind of a black box. I'm going to make it much simpler. Yeah, we could go into technical details, but you don't really need that to get the gist of it. So I'm going to use another simple analogy. I want you all seriously to picture your kitchen sink at home and picture a glass sitting in the sink, about half full, and you want to know how long the glass has been there. So it's a glass in your kitchen sink. You can all do that. We're not talking about radiometric dating right now. You're talking about a glass in your kitchen sink. Well, you make three major observations about the scenario here. Number one, you note the size of the glass sitting in the sink. Number two, you note it's about half full of water. And number three, you notice it's dripping about a drop per second. So you take a look at all of that, you do some calculations in your head, and you say, I think probably maybe about an hour. I think it might take an hour to fill it halfway with the slow dripping like that. You took a real process that nobody denies. The water dripping, it is a process everyone can see. There's no question. But you took that process and you made three major assumptions about it, and you didn't even realize it. It's going to surprise you. First of all, you all assumed the glass was empty to begin with, didn't you? Why? You don't know it was empty. You weren't there when someone put it in the sink. You just made that assumption. Kind of interesting. Number two, you assumed no other sources of water entered that glass. It's just the dripping. What if someone put the glass in and it was empty, but someone came with a bottle of water and filled it up halfway, walked out. You walk in 2 seconds later, it's been there an hour. No, it's been there 2 seconds. But there was another source of water. You also assumed that there was no water leaking out the bottom. It was another partial assumption related to water sources. Thirdly, you also assumed the drip rate that you're seeing right now, about a drop per second, that it was always a drop per second. Well, if the glass is empty and that's the only thing that went in there, yeah, it might take an hour. What if the glass was empty, but whoever said it, they turned the faucet on full blast, and as soon as it got halfway, they slammed it shut, and then it just started dripping. They walk out. You walk in 2 seconds later. It's been there an hour. No, it's been there 2 seconds. but the water was flowing a lot faster before you got in there. You just assumed it was always at the rate you see right now. That's what happens with radiometric dating. And if the assumptions are wrong, the conclusions will be wrong. So let's take a look at a specific example. We have uranium-238, and it decays into lead-206. Uranium-238 is radioactive, it's unstable, so it decays and it ends up lead-206, and it decays really, really slow. We can see it today in the laboratory, no one questions it. In fact, it would take about 4.5 billion years for half of it to decay into lead. That's the rate we see. Not that we're standing there that long and know, but just at the rate it's going today, it would take about 4.5 billion years for half of it. That's called the half-life. It goes really, really slow. That's a fact. So you take a look at a rock. It's got uranium-238 in it and lead. That uranium is decaying slowly into lead, and it's accumulating, isn't it? So what they do is that they measure the amount of lead that's in there, and they say, wow, for that much lead, well, that would take 1 billion years going that slow. And at that rate, yeah, that would be true. So they say the rock is 1 billion years old. But they made 3 major assumptions, just like you did with the kitchen sink. You assumed the glass was empty to begin with. They assume the rock was empty to begin with, meaning no lead at the bottom. It was just uranium, so it was empty. No lead to begin with, so any lead you see came from the uranium. Well, that's an assumption. They don't know that. And we find rocks today that are newly formed, and they have lead in them right away, which would throw off the date because the assumption is wrong. Number 2, you assumed no other sources of water went into the glass in your sink. They assumed no other sources of lead entered that rock. Well, groundwater can leach these elements in. It can also leach them out. So to say this rock sat there in the earth for 1 billion years and it was never affected by its environment, with water flowing through it the whole time in a sense, that's a terrible assumption. They call it a closed system argument. Well, it doesn't make any sense to say that rock wasn't affected by anything for 1 billion years. Last assumption, you assume the water that you're seeing dripping now, very slow, was always dripping slow. Well, they assume that the rate of decay that we see today was also constant. It's always slow. It's slow today, no question, but they assume it was always slow throughout history. We're going to take a look at that in just a little bit more detail. I'm trying not to get overly technical, but when uranium-238 decays into lead-206, it doesn't just jump right into lead. It goes through a series of isotopes and things all the way through about 16 changes because it's radioactive until it finally hits lead-206, which is stable, and it's not going to decay anymore. And along the way, it gives off helium nuclei, which capture some electrons, they become helium atoms. So helium's being created. In fact, 8 times. As it's decaying, 8 times helium's being created. What's interesting about helium is it's really slippery. So when it gets created, it doesn't hang around the rock. It leaks all the way out of the crystals, out of the rock, and into the atmosphere because it doesn't want to interact with anything else. So if the rock is 1 billion years old and helium's being created, it has plenty of time for it to get out of that rock. It's not going to hang around. Well, we have discovered there's still a lot of helium in these rocks, which means there hasn't been enough time for it to leak out. Yes, it was created, but it hasn't been 1 billion years. It would be pretty much all gone. It's still in the rock, so something else has to account for that. Well, maybe it decayed much faster than we see today in the past. If it decayed really fast, all the helium would have leaked out, but there wouldn't have been enough time for it to get out of the rock yet. This is evidence that decay rates were probably much faster in the past. And I'll show you something technical, but I'll just explain the easy part of it. This is just a visual thing at this point. Just have fun with the visual. This is a graph. There's a green line and a red line. This represents different leak rates of the helium getting out of the rocks. Again, we don't need to get overly technical, but it just represents how fast is helium leaking out of rocks. The green line represents the rate it would be leaking out if the Earth has had a short period of history, 6,000 years. It would appear there on the graph. If the other view is right, that the Earth is 4.6 billion years old, then we would see this line at the bottom here, the red line. If the Earth was really old, that would be represented on the graph. These two lines differ from each other of a factor of 100,000. So they're not kind of close to each other. They're really night and day difference of what we would expect according to how old the Earth is. Okay, so this is what we're guessing we should see if the Earth is young, if it's old. They went out and dug up rocks from deeper in the earth where there was more pressure, more heat, which would have different leak rates. The farther down it is, the hotter it is, the faster it's going to leak. So they dug up these rocks and they measured how fast it was actually coming out. So they took real rocks, took real data, and then they plotted the real evidence on the graph. Is it going to more closely line up with the idea that the earth must be young, or that it's not, billions of years old? Here's the actual data on the graph plotted. It's almost a perfect fit. It's almost too good. Usually when it's that close, you're like, okay, you guys are manipulating the data. This was the real data. I'll just show you this again. I love the animation. It's exactly what the young Earth creationists expected from the helium leak rates, because they believe the Earth is relatively young. It's way off what it should have been if it's billions of years old. This is evidence that the decay rates were sped up greatly in the past, maybe partially during creation week, maybe during the flood, maybe up to 1 billion times faster than we see today. So what you would think would take 1 billion years could happen in the year during the flood. This is actually, again, very powerful evidence that one of those assumptions is wrong, to assume the decay rates have been constant throughout history. It's actually very, very powerful evidence. The literal 6-day creation, powerful evidence of greatly accelerated decay rates. Okay, move away from some of that technical stuff. Here are some example errors. When they're doing radiometric dating, it's not perfect like, right every single time. There are issues most of the time. And I want to point out the difference between precision and accuracy. If I told you I weighed 189.11538845 pounds, that is extremely precise. It's not accurate. I don't know what I weigh, maybe 184. So the number is wrong, but man, is it precise. And we get so impressed by precision. So when they tell us some numbers behind something, like, wow, these guys are so smart, how do they do that? It doesn't mean it's right, just because they're having some precision behind it. So don't get overwhelmed by that. Here's some example errors of when they were using the dating methods and they were obviously wrong. This is Mount St. Helens. It erupted back in 1980. I think last summer or the summer before, I was co-leading a tour out there. Fascinating place. So it erupts in 1980. 6 years later, there was a lava dome that formed where the volcano had blown out. So this lava dome formed in 1986. Lava comes up and hardens. Brand new rocks. They were born in 1986. No one questions that. We saw it happen. They were born in 1986. They did radiometric dating in 1996. Even if you don't like math, that's a 10-year difference. So 10 years later, these rocks are 10 years old, right? We know that. We saw them form. They used potassium-argon dating on it, and they ranged from 350,000 years to 2.8 million years old. They're 10 years old. Totally wrong. That's interesting. Mount Ngauruhoe in New Zealand. There were some lava flows between 1945 and 1975, rounding it off 50 to 80 years old. We know that's how old these lava flows are. That's when these rocks formed, 50 to 80 years ago. They used potassium-argon and isochron method on there, and the dates range from 2.5 million to almost 4 billion years when they were 50 to 80 years old. Something's wrong with the assumptions. If they're way off on rocks of known ages, how can we trust them for methods of rocks where we don't know the age? You just find a rock, you don't know the age. Why do they just magically trust it every time when they're off when we do know the age? That doesn't make any sense. Grand Canyon, and we've all seen the cutouts here. I'll talk more about that. Lava flows. There were lava flows at the top and the bottom. Well, they say there are hundreds of millions of years of age difference between the top of the canyon and the bottom of the canyon. Well, again, radiometric dating, 1.1 billion years for both of them. The date's wrong, but it's the same. It shouldn't be the same for both. If they are supposedly separated by hundreds of millions of years of Earth history, something's wrong with the method. And the date errors or inconsistencies are the rule, not the exception. They might say, well, yeah, there's going to be some contamination once in a while, and we could throw some of those out. No, this isn't just an exception. This is happening most of the time. So it's something very, very significant. Then some 27 amphibolite samples, these are metamorphic rocks, measured towards the bottom of the Grand Canyon, around the Vishnu schist area there. These things range from 405 million to 2.6 billion. That is a 600% difference in ages by using the same rocks in the same areas. Why are we so confident with radiometric dating? Because you don't see this published. They just throw it out. They just publish one that matches what they want, and that's all you ever see. It's like, wow, these guys are so smart. It's fascinating. So we're going to move into carbon-14 dating because everyone's heard of carbon-14 dating and maybe intimidated by this. I call this the carbon-14 Trump card, not President Trump, but you know what a Trump card is. It's something that trumps all the other cards that are out there. This is how this typically works. You got a skeptic and a Christian talking, and the skeptic says, you really believe all that Bible stuff and creation and everything? And the Christian might say, well, yeah, I guess so. Well, what about carbon-14 dating? And the Christian might say, well, I'm not sure. What's your point? Well, carbon-14 dating proves the earth is billions of years old and the Bible's wrong. And the Christian might say, well, I don't really know anything about carbon-14 dating. I just believe the Bible. Yeah, you have your little myth faith there in this antiquated book that's been disproved by science, but I live in the real world and we prove things in laboratories, and they walk off. And the Christian is just humiliated and they're thinking, you know what, I'm never bringing this up again. It's embarrassed. I even wonder if what I believe is true. That's typically what happens. Now, if anyone ever says anything like that to you, it proves one thing. That person, they don't know anything about carbon-14 dating. Seriously. They're repeating what someone else told them. And that happens all the time. Even, Christians, everyone does it. It's human nature. They hear something that makes sense to them, and then they just repeat it, but they don't know the backing to it. I'm going to tell you two important points. Even if you forget everything else, you can remember these two things when someone brings up carbon-14 dating. Number one, it is only used to date materials that were once living. You can't date rocks with it. So when they say, dates the earth at billions of years old, no, you can only date things that were once living, bones and flesh and things like that. And number two, scientists do not use carbon-14 to date something that they believe is probably 100,000 years or older, maybe even 80,000 years or older. Why? Because it doesn't last that long. It can't physically produce ages for anything that would be that old because it doesn't last that long. It's like an ice cube. If I told you I had an ice cube sitting up on this table, it's been here for 500 years, that's crazy. It would have melted after maybe 10 minutes, right? Ice cubes don't last that long. The same thing with carbon-14. It's gone after a few tens of thousands of years. So once you get to maybe 80, 100,000 years, there's nothing there to measure. So there's not a scientist on the planet who uses carbon-14 to date something that they think is 100,000, 2 million, 1 billion years old. They don't even do that. But the layperson says carbon-14 dating disproves the Bible, proves the earth is billions of years old because they don't know anything about carbon-14 dating. So I'm going to explain carbon-14 dating in a little more detail. But before we talk about carbon-14 dating, we'll talk about what carbon-14 is, what it is, and from whence does it hail. Well, how does it get here, basically? Well, our atmosphere, the air that we breathe, yes, you breathe oxygen, but that's only about 21%. Most of what you're breathing, 78%, is nitrogen. So the air you're breathing is nitrogen and oxygen. Well, what happens is sunlight comes into our atmosphere and it messes with nitrogen-14, it bangs into it in a sense. And when it does, it converts it to carbon-14. So the sunlight comes into our atmosphere and it creates carbon-14 in the atmosphere. Carbon-14 is radioactive. It's unstable. It doesn't want to stay carbon-14. It wants to go back to what it was doing, wants to turn back into nitrogen-14. So the sun creates it, but it's unstable. It wants to go back to nitrogen-14. Well, while it is carbon-14 and unstable hanging out in the atmosphere, it can connect with two oxygen molecules and make carbon dioxide. We're all familiar with carbon dioxide, especially with all the climate change hype. Don't get me started on that. It's another talk. I've already given it. But carbon dioxide is a good thing, especially with photosynthesis. Plants take that in. So as they're taking in this carbon dioxide that happens to have the radioactive portion in, carbon-14, radioactive, is getting into the plants, and it's getting into the trees. And then the animals are eating the plants and the grass and the trees, so now it's also getting into them. And then some of us, like me, will eat the animals, and then it gets into us. So summarizing, the sunlight creates carbon-14 and it gets into all living things. That's the simple version. Sun creates it and it gets into all living things. Now, what happens is things die. Sometimes they get buried. If they get buried rapidly, they could be preserved. So let's say this cow died and got buried. It's got carbon-14 in it. It was alive. It was taken in as it was eating. Well, scientists have discovered that once things die, they stop eating. So it has carbon-14, and that's going to decay away, but it's not going to replace it anymore because it's not eating again. So it's going to go away. So what scientists do is they measure how much carbon-14 is in something. They dig it up, and they try to figure out how much carbon-14 is in it to figure out how long ago did it stop eating, how long ago did it die. That's how carbon-14 works. So let's say this blue rectangle represents the carbon-14 in a cow that died or whatever. They dug up the skull and they're measuring the carbon-14. So initially, it's full. It has 100%. It just died. It's got everything that it just had because it just died now. Well, if 6,000 years would go by, it would be down to half of what it used to have. That's the half-life. Technically, it's 5,730 years. We'll just round it off. So 6,000 years after it dies, it's going to lose half of its carbon-14. So it's gone down to half. If another 6,000 years would go by, it would be down to half again. Half of a half is a quarter. And if another 6,000 years went by, we'd be up to 18,000 years ago, it would be down to 1/8 of what it had, and then down to 1/16, and it just keeps going. So they measure the level that it has, and they try to figure out how long ago did this thing die. That's how it works. It's not that complicated. I think you'll get the gist of that. But there are a bunch of assumptions behind this method, and if you don't take them into account, your dates can be way off. And I'm not going to go through many of them. I think I'll just mention one right now, or two actually. The past ratio, they assume. Today we have a ratio of the radioactive carbon-14 and carbon-12. It's like 1 to a trillion. There's a certain ratio. They assume that ratio has been constant throughout history. That doesn't make any sense. There are reasons to believe it wouldn't be the same ratio today, and here's why. The Earth's magnetic field. I'll be talking about that again in just a second. But the Earth is like a giant magnet, and the magnetic field protects us from solar radiation. But this magnetic field is dwindling and getting weaker and weaker. Again, I'll bring that up in just a minute here. But that means it was stronger in the past. Well, it's protecting us from solar radiation. That means in the past, especially before the flood, it would have been really strong and protecting us a lot less of this harmful radiation coming through. Well, with less radiation coming through, you'd be making less carbon-14. So things that lived before the flood, they wouldn't have had nearly as much carbon-14 as things do today. So instead of an initial amount like that, what if it started out with that? And then from that small amount, it started to decay, and then it goes to another half-life. So we think it went that whole way. So now they dig something up that didn't have much carbon-14 to begin with, and the little that it did have has decayed even further. So they say, this thing died 28,000 years ago. No, it's probably buried in the flood about 4,500 years ago, but you assumed it had the same level of carbon-14 that we have today. But there are great reasons to believe, no, it would have been much less in the past. So things that they're dating today appear much older than they really are because they're not taking into account those assumptions. And there's a whole list of other ones. I'll skip those for now. I'm going to show you some oopses where they were doing carbon-14 and it didn't turn out the way they wanted it to. Saber-toothed tiger bones. According to their secular narrative, the bones should be 100,000 years old. That's what they're expecting, because that's when they became extinct, they believe. Well, they carbon-14 dated it, and it said that it died 28,000 years ago. Now, I think this number is wrong. It should be adjusted even further down. In fact, when you take all the assumptions into account, even that would come closer into a range of about 4,500 years ago. But you can forget that for now. Just take into account this number is only almost like a quarter of what it should have been. It's way off of what they were expecting. Something's wrong with the assumptions that they're not taking into account. Freshly killed seal. Caveat, no seals were harmed to make this PowerPoint slide. This guy was playing with his family. I said, hey, could you come over here, lay down, and pretend you're dead just for a picture, and I'll give you some sardines. Anyway, freshly killed seal. It just died. It should have an age of 0 because they measure back to when something died. It should yield an age of 0. Carbon-14 said it died 1,300 years ago. Something's wrong there, right? How about a living snail shell? It's still alive. It certainly should have 0 age because it hasn't even died yet. Carbon-14, it died 27,000 years ago. Something's wrong with the method and the assumptions. So if carbon-14 dates are often an error when testing things of known ages, why is it trusted so confidently in things where you don't know the age? Doesn't make sense. And now some examples of carbon-14 where it ain't ought to be. If things are really old, shouldn't have any carbon-14 in it. If they're, 80,000, 100,000 years old, carbon-14 would be long gone. Can't find any carbon-14 there. Well, how about coal? Coal is supposed to be a few 100 million years old. We have yet to find a single piece of coal on this planet that doesn't still have carbon-14 in it, which makes sense. If it was produced during the flood, buried about 4,500 years ago, we would find carbon-14 in it. But if it's 100 or 200 million years old, which is what they tell us, because it takes millions of years to form coal and all that, then why are we finding carbon-14 in coal? Dinosaurs. Now, we know dinosaurs became extinct about 65 million years ago. Now, you don't actually know that. You've just been told that over and over and over and over and over. So at a certain point, it's like, you don't question that, because yeah, you're right and they're all wrong. You just hear it enough, it becomes an absolute fact. Well, guess what? We have carbon-14 in dinosaur bones, but it will only last a few tens of thousands of years. How can it be in those bones? We'll talk more about dinosaurs in a bit as well. Diamonds. Diamonds are supposed to be 1 to 3.5 billion years old. They can't have any carbon-14 in them. Guess what? They have carbon-14 in them. Well, they got contaminated, because that's what happens, when these errors come up, is that carbon-14 from something else contaminated. Oh, they are so careful when they're doing their dating now, because that can happen. So they're very careful. And diamonds are the hardest natural substance known to mankind. You can't contaminate them. Any carbon that's in them must have been trapped in it when they were formed. And if it's still there, that means these diamonds are thousands of years old, not millions or billions of years old. Fascinating. We're going to move quickly into some young age indicators, some things from science that show us it just can't be millions or billions of years old. And just samples, again, just highlighting a few of these. And again, a lot of these, they don't tell you the exact age, they put that upper limit on it. So I also want to introduce this, rescuing devices. What's that? A rescuing device is something someone comes up with when you're challenging them with something that goes against their particular view. There's nothing wrong with a rescuing device. The question is it a valuable response? Is it a valid response? And a lot of the rescuing devices that the secular community comes up with are not valid at all. But I want you to know that they're out there. I don't have time to bring up every evidence for a young earth and then bring up what they say, and then say what I would say to that, or what we would say to that, and then what they say to that, and go on and on. We get through one thing, and it'll be hours later, and it'd be so boring. But I want you to be aware that they exist in case you tell one of these to someone, and they instantly say, well, what about this? Oh, he didn't mention that. I can't mention them all, but they exist, and there are great responses on the young earth creation side to any of these challenges that they're bringing up. And I'll mention a few of those so you know what they're like. Earth's magnetic field. I mentioned that the Earth is like a giant magnet. And if any of you have had magnets at home, you know how they work. They do decrease in power over time. So the Earth has this giant magnetic field, which God designed for us, which is great because it protects us from harmful radiation. But it is dwindling. It is weakening. In fact, it has a half-life of 1,400 years. We've been measuring this thing for a long, long time. Every 1,400 years, it's half as strong as it used to be. Now here's a timeline with today on the left side over there. We're going to take a look at what this means. So we're putting an X up there. X is the value of the magnetic field today. Let's look at what happened in the future. Well, 1,400 years in the future, it would be decayed down to half of what it is today. And then if we went another 1,400 years to 2,800 years in our future, it would be down to 1/4, and then 1/8, and 1/16. It's dwindling and decaying that way. We've been measuring it for a long time. That's not the interesting portion. Scientists aren't really worried about what's going to happen in the future. It has nothing to do with gravity. It's not that as the magnetic field goes down, we're going to be floating off the Earth. Gravity has to do with the mass of the Earth. What they're curious about is going the other direction, looking into the past. So now here we are today on the right side. So this is the value of the Earth's magnetic field today. You go 1,400 years ago, it would have been twice as strong as it is now because it's decayed from that to half. If you went another 1,400 years to 2,800 years ago, it would have been 4 times as strong because it's doubling. Well, 2,800 years ago was basically between the fall of the northern and southern kingdom in the Old Testament. So it's about the time period that we're talking about. The Earth's magnetic field would have been 4 times as strong as it is today. Okay? If you went back another 1,400 years, then you're 8 times as strong, and then 16, and then 32, and then 64. The question is, how far back can you go and have an Earth that it's going to hold together? Because the stronger the magnetic field gets, the more heat you have in the core. You go back too far, the Earth would just be blown apart. So what's a reasonable limit? Well, 10,000 years. You try to go much beyond that, and you're not going to have an Earth that holds together, a life that's going to be possible. This is not saying the Earth is 10,000 years old. This is a limit. Could the Earth be younger than that? Easily be younger than that. This is just an upper limit. But they tell us the Earth is 4.6 billion years old. And this is saying, no, you can't really go back beyond 10,000 years. Here's David Stevenson, a planetary scientist from Caltech. He said, there's a problem with our understanding of the Earth's core. The problem is a serious one. We do not understand how the Earth's magnetic field has lasted for billions of years. We have less of an understanding now than we previously thought we had a decade ago. It is a huge ongoing problem. How can that magnetic field last for billions of years? Okay, rescuing device. This is what they would say. You have reversals of the field. So yeah, it decays, but then it reverses and it goes back and forth and back and forth. There have been reversals of the Earth's magnetic field. We have evidence of that. That's not a question. But it doesn't fit with millions and billions of years, but it does fit with the creation narrative. And here's a graph. I'm not going to go through the details for now. I just want to show it to you that God creates everything, and the field starts to decay. During the flood, which was cataclysmic across the globe, it wreaked havoc with the Earth's magnetic field, and it was reversing very rapidly. We could see that in the seafloor. As the seafloor is coming up and spreading rapidly, the fields are reversing, and we see that pattern. It's not coming up, the seafloor isn't coming up slowly over millions and millions of years, which is say it came up rapidly during the flood, and then it got back up to its normal rate here, and then it starts to decrease again like it was before the flood. This fits in very well with the creation scenario. If you want more detail, Dr. Russell Humphreys, a good friend of mine, physicist, has written a lot about this, a lot of technical physics behind this, but it is so solid and explains this is evidence for a young Earth that doesn't fit in with millions and billions of years. And then another rescuing device, they call it the dynamo theory. I'm going to skip a lot of those details, but their dynamo theory contradicts some laws that we have in physics, which is a big problem, and it doesn't explain some observed electrical measurements and reversals and all that. So again, they'll come up with something, but it doesn't cut it. I just wanted you to know some of that. Mentioned dinosaurs before. And again, when you think of dinosaurs, you instantly associate dinosaurs with millions and millions of years. So how does that work? Well, guess what? Most dinosaur bones we discover are still fresh. They haven't even fossilized yet. They were 65 or 100 million years old. They should have fossilized a long time ago, but they're still fresh. So bones do not have to be turned into stone to be fossils. And usually most of the original bone is still present in a dinosaur fossil. Modern bones that fall into mineral springs can become permineralized or fossilized within a matter of weeks. This can happen quickly with minerals like that. So if they've been hanging around for 65 or 100 million years, should have fossilized a long time ago. So why are they still fresh? Well, if they were buried in a flood 4,500 years ago, yeah, we could still find them being fresh. Already mentioned, we have carbon-14 in them. That shouldn't be there if they were millions of years old. And we now have soft tissue and red blood cells in dinosaur bones. Now, I know you're all sick and tired of hearing about soft tissue and dinosaur bones, right? No? Oh, maybe that's because they just discovered that a couple days ago and it hasn't hit the news cycle yet, right? How about like maybe 1995? They've known about this for a long time, but they cannot explain it. I'm going to show you a short video. There's no audio. You are about to see something that very few people on the planet have ever observed. You're going to see dinosaur soft tissue under the microscope being stretched and snapped back. That is dinosaur soft tissue. Does that look 65 or 100 million years old? Not a chance. No way. Those biological materials can't possibly survive that long, and scientists know that, so they're kind of panicking. That's why they're not talking about it routinely. So creationists, we have to go dig up our own bones to do the testing. I did a dinosaur excavation a couple summers ago, and Western Colorado. It was fascinating. We sent the bones over to the University of Liverpool to be tested. I was just over there last August lecturing in Oxford and London. But we're finding this over and over and over in bones that are supposedly 100, 150, 200 million years old, because I think they were buried in the flood about 4,500 years ago, and they don't have an answer yet for that. So it's very quiet. We also now have DNA fragments in dinosaur bones. DNA is more fragile than red blood cells and soft tissue. How is that possible if they're millions of years old? It's not. But if they were buried in a flood 4,500 years ago, we could still see some of that DNA. Rescuing device, if you read anything, the only thing they can talk about right now is the presence of iron. If iron is in an environment, it could potentially preserve things a little longer, not millions of years. In fact, you have too much iron, it's going to destroy things, and to get the iron in there, generally you have to bring water in, then that's going to destroy things. There's lots of lectures on this. Iron is not an answer. That's why they're just timidly, well, we got a solution, it's iron. No, the research doesn't back it up at all. Otherwise, they would, every cover, magazine, be dinosaur, soft tissue, they'd be bragging about it if they could explain it, but they can't. So you're not hearing about it. So creationists, again, we're having to do our own research and publications. So how do they determine the age of the dinosaur bones? This is really interesting, and you'll probably be really shocked and really disappointed when you find out the details. When they dig up dinosaur bones, they don't have tags with them saying how old they are, 65 million years old. The scientists have to assign an age to it, and this is where we run into problems. So a paleontologist will dig up some bones out there, and then they'll bring it into a laboratory to another scientist who does dating. And the scientist, she wants to know, where'd you find this thing? What does she care? Just give us a date on the bone. No, she wants to know where in the geologic column, because they've assigned all those ages. They assigned all the ages before they invented radiometric dating. Got names on them, and got ages, how many hundreds of millions of years ago that they were laid down, before we had the radiometric dating. She wants to know where they found it in the column so she can figure out how old it's supposed to be. So she's told, well, this is T-Rex bone, and they died out at the top of the Cretaceous about 65 million years ago. Now she's got a target. It's going to be about 65 million years ago, because we know that. Well, no, you don't know that. But that's their target. So they don't date the bone. Why not? Well, it's too old to date. There won't be any carbon-14 in that, 65 million years old. Wait a minute. This is the whole question. How old is the bone? You don't know, so don't tell me you know it's too old to date. That's why we're bringing it in. But no, because of their bias, nope, we're not going to date the bone. You can't. There shouldn't be anything in there. Well, we are dating them today, and they have carbon-14 in them and all that, but they're just ignoring it, put it off to the side. So they don't date the bone. Oh, so do they date the layer the bone was found in? Nope. Those are sedimentary layers, fragments of other rocks. You can't use radiometric dating on sedimentary layers. So they're not dating the bone, they're not dating the layer the bone was found in. So they bring in a nearby igneous rock that was by the layer where the bone was found, and you can do radiometric dating on igneous rocks. So that's what they're going to do. And there are multiple methods. So first they use uranium lead, and it says 1.1 billion years old. Well, we know that's wrong. We could throw that out. Something went wrong there. Usually dismiss that one, so they throw it out. Then they use rubidium strontium dating. That says 103,000 years old. Way too young. Must have got contaminated. We can just throw that one out. No one will question that. Then fission track dating, 25 million years. Well, we're getting closer, but still that can't be right. So they throw that out. Then they use potassium argon, 68 million years old. See, they were thinking 65. Potassium argon says 68. So here's a summary of the whole thing. Did they discover dinosaur bone? Yeah, no question. Was it a T-Rex? Yep, no question there. Should it have been about 65 million years old according to their secular narrative? Yep, that's what they would expect. Potassium argon says 68 million years, and then that gets published. And the public says, wow, those guys are so brilliant. I don't know how they do it, but I'm glad they can figure that out. That's impressive. You can't argue with that. Well, yeah, you can if you knew what was going on behind the scenes. That's not very scientific. So those are just a few examples. That was part one. There's so much more. That's why we have to have part two. There's going to be a lot of other examples that, again, I'll just introduce you to so you can see how many things. Plus, we're going to take a look at what I call icons of age, things that when you see them, you just instantly think, well, I mean, that's got to be millions and billions of years, like the dinosaur bones. We're going to look at a bunch of those, and then we'll wrap things up at the end of that. So I will close again in a word of prayer. Dear Heavenly Father, just thank you again for this session we've had to take a look at something that is related to your word, because you address the origin of life in the universe, and we need to pay attention to that. But help us to think clearly as we're looking at science, which is a gift from you as well. You invented science, and science was birthed out of the Christian community, so we thank you for that. We thank you that it backs up what your word has been saying all along, and we just pray all these things now in Jesus' name. Amen.
We hope you enjoyed this presentation and trust it was an encouragement to you. For more information about our ministry and resources, visit us online at thestartingpointproject.com.